Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be identifying transformations of geometric objects. Now, before we do, let's review some of the transformations we've learned about so far. So remember, a translation is just a slide to the right, left, up, or down. And when we write the algebraic rule, we simply take the x-coordinate and either add or subtract a number. I'll call that number A. And then we take, whoops, why did I close that parenthesis? Sorry about that. And then we take the y coordinate plus or minus a number. I'll call that B. So that's how we write our algebraic rule for translations. You're just going to take your x coordinate and add or subtract something, and then your y coordinate, add or subtract something. All right? A reflection is just a flip that produces a mirror image. So if we reflect over the x-axis, your x will stay the same, but the y will change to the opposite. If we reflect over the y-axis, the y stays the same, and the x changes to the opposite. Okay? A rotation is a turn about the origin. So if you go 90 degrees clockwise or 270 degrees counterclockwise, that's the same rotation. And what happens is the x and y switch places, and the original x changes to the opposite sign. So our rule for this is y, comma, opposite x. Now, 180 degrees has the same equation whether it's clockwise or counterclockwise, and it's just opposite x, opposite y. Now, 270 degrees clockwise is the same as 90 degrees counterclockwise. And just like our first rotation, the y and the x swap places, but in this rotation, it's the y that changes, the original y that changes to the opposite. Now, let's practice identifying transformations and telling their algebraic rule. So in example 1, it says, in each graph below, determine the transformation needed to map the pre-image onto the image. Give a verbal and an algebraic description of the transformation. So in problem A, we have triangle ABC is transformed to create triangle A prime, B prime, C prime. And we want to know, is it a translation, a reflection, or a rotation? Well, hopefully you can see, if you just look at point C, you can see it's 2 units above the x-axis. C prime is 2 units below. So this is a reflection across the x-axis. And remember, the rule for reflection across the x-axis is the x stays the same, but the y changes to the opposite. All right. In problem B, we have triangle ABC is transformed to form A prime, B prime, C prime. So we want to tell, is this a reflection, a translation, or a rotation? So since the orientation of this triangle has changed, then we know this has to be a rotation. So we can, it's either, here we went 1 quadrant to the right, so that's a 90 degrees clockwise, or it could go 1, 2, 3 rotations, 270 degrees counterclockwise. So whenever we have a 90 degree clockwise or 270 degree counterclockwise, we know that the x and the y are going to swap places. The x and the y are going to swap places, and we'll take the opposite of the original x value. So y opposite x. All right. Problem C. Triangle ABC is transformed to create triangle A prime, B prime, C prime. And we want to know, is this a reflection, a translation, or a rotation? So in this triangle, the orientation remained the same. It's oriented in the same direction. So this looks like a translation. Now, to describe the translation, I'm just going to focus in on one point. I'll use point. You can pick any point. I'm just going to pick point B, and I'm going to compare it to point B prime. So I want to know, how did we have to move my pencil to get from B to B prime? Well, I know I'm going to have to go to the right. Let's see how many. 1, 2, 3, 4. So translation to the right, 4. And then down 1, 2, 3, 4, 5. Down 5. Now, the way we describe this algebraically, the x moved to the right, so it increased by 4. The y moved down, so it decreased by 5. So there's our algebraic description. All right. Problem D. We have triangle ABC is transformed to create triangle A prime, B prime, C prime. Now notice that the orientation of this triangle changed. So this is a rotation. And let's see how many times it rotated. It went 1, 2 quadrants this way, so that would be 180 degrees clockwise. Or if I went this way, that's 1, 2 quadrants in that direction, or 180 degrees counterclockwise. And the rule for 180 counterclockwise or clockwise is opposite x, opposite y. All right. Problem E. We have triangle ABC is transformed to produce triangle A prime, B prime, C prime. What I'd like you to do is pause the video and try to determine what type of transformation it is. Give a verbal description and then an algebraic description. When you're ready to check your answer, press play. All right, welcome back. I said this was a translation. And to get the verbal description, I focused in again on one point. This is my original point, B, and I want to see how am I going to have to move to get to B prime. So I'm going to have to go left, 1, 2, 3, 4, 5, 6. So left, 6, and then up, 1, 2. So my x decreased because it moved to the left, so x minus 6, and my y increased because it went up 2. All right. All right, pause the video and try problem F on your own. When you're ready to check your answer, press play. All right, welcome back. I said this was a reflection because I noticed that point B is 2 units to the left of the y-axis, and point B prime is 2 units to the right of the y-axis. So here's my reflection line. So it's a reflection across the y-axis. Now, in a reflection across the y-axis, the y stays the same, but the x changes to the opposite. All right? Example 2. For each algebraic rule, describe the transformation. Now, I'm going to pick an imaginary point to help us. And I can pick any point I want, but I want to make it easier on us. So I'm going to pick a point where both numbers are positive. In other words, a point in the first quadrant. So I'm just going to use, for my arbitrary point, 3, 2. That's my original point. Now, if I transform it according to the rule opposite x, y, I would get negative 3, comma 2. So let's plot this here. Let's say 1, 2, 3, 1, 2 would be right here. This is my original point. And if I plot negative 3, positive 2, that would be right here. So hopefully you can see that this is a reflection across the y-axis. So here's the y-axis. We reflect, this point is 3 units to the right. This point is 3 units to the left. So a reflection across the y-axis. All right. So let's go back to my arbitrary point for problem B. My arbitrary point, let me change back to blue, was 3, 2. If I take the opposite of x and opposite of y, that would give me negative 3, negative 2. So let me draw a coordinate plane again here. 1, 2, 3, 1, 2. There's my original point, 3, 2. And I want to go 1, 2, 3, down 2. Here's my new point. So this point rotated 1, 2 quadrants clockwise. So that would be 180, a rotation, 180 degrees clockwise or counterclockwise. All right. Now we're going xy. So if my arbitrary point is 3, 2, this says I'm going to switch the x and y and take the opposite of the original x. So that's going to look like this. 1, 2, 3, 1, 2. There's my 3, 2. And 1, 2, negative 3 ends up there. So this is a rotation. I could go 1, 2 quadrants. Wait, what did I do wrong? Yep, I plotted that wrong. Thankfully, I caught it before I finished this problem. I plotted this point in the wrong place, so let me erase that point. Okay, my original point was 3, 2. I was supposed to plot 2, negative 3, which would be right here. So this is a rotation 1 quadrant, 90. Whoops, I meant to write rotation. Rotation 90 degrees clockwise, or I could go the opposite direction. I could go 1, 2, 3 quadrants counterclockwise, which would be 270 counterclockwise. All right. In our last example, let's write my arbitrary point. They want me to keep the x the same and change the y to the opposite. So 1, 2, 3, 1, 2. And my new point would be at 3, negative 2. So this point just reflected across the x-axis. So let me draw on the x-axis. Here's our reflection line. This point is 2 units above. This point is 2 units below. All right, example 3. For each point shown below, use the description to write an algebraic rule for the transformation as well as the coordinates of the point after the transformation. So in problem A, it says point A is at negative 5, 5, and it's reflected across the x-axis. So when we reflect across the x-axis, the x stays the same and the y changes to the opposite. I'm sorry, I was supposed to write the rule right here. The rule is the x stays the same, the y changes to the opposite. So my new point would be negative 5, x stayed the same, And then the opposite of positive 5 is negative 5. All right, problem B. Point B is negative 9, negative 3, and it's translated 4 units left and 2 units down. So the rule would be x minus 4, because we're going to the left, and 2 units down would be y minus 2. So I'm going to take my original x, negative 9, and subtract 4, then take my original y and subtract 2. And now let's see what we get. Negative 9 minus 4 would be negative 13. Negative 3 minus 2 would be negative 5. All right. Point C is 7, 6, and it's rotated 180 degrees clockwise. When we rotate 180 degrees, it's opposite x, opposite y. So my new point would be negative 7, negative 6. All right. Point D is 2, negative 4, and it's rotated 270 degrees clockwise. What is the rule for 270 degrees clockwise? Well, it's opposite y, comma x. So this means the x and y are going to swap places. So negative 4, 2, and then take the opposite of the original y. So the opposite of negative 4 is positive 4. So our new point will be 4, 2. And that concludes today's lesson, identifying transformations.